Okay? So this is just the statement that describes Hess's law, and then we'll go ahead and do it. So basically it says you can take the sum of all these reactants, and when you do that, and you do it in a correct way, to where you're canceling out your reactants and products, and you come up with a final reaction, that final reaction is going to equal the sum of your other reactions. So when you sum everything up, we'll get whatever the reaction is without actually doing the reaction. Okay? So here's the first example. It's a real simple example. I will put that back up if you still want to copy it. It's in the book, Hess's Law. But we'll go ahead and get the problem, and I can put that back up. So here's two reactions that we know the energy associated with. Okay? And so what we'll need to do is we need to rearrange the reactants sometime in which to fit the final outcome. So what I do is I like to look at one reactant or product at a time and just see if it matches up. So I look at N2 and I match it up with the N2 up here. So they're on the right side. And then this one doesn't have an N2 in it. So when we sum them, they have to be on the correct side. The N2 would have to be on the reactant side when we do it. So the next thing I look at O2, and it's on the right side. It's on the correct side. Okay? Now, when I look at the NO2, it's not on the product side. It's on the reactant side. So if I see one like that, the first thing I'll do is I'll rewrite it in the opposite way, in the reversed reaction. So what I would do is I would go ahead and rewrite this, and I'd write it as N2O4 arrow gives you 2NO2. And then when I do that, what happens to the sign? We talked about that, I guess. It switches, it flips. So then this becomes plus at this set in time, okay? That's going to be plus. So what I can do is I can just go ahead and erase this, which you guys can't, I can't either. But I'm going to go ahead and just get rid of it. And then I'm going to see how things will match up. Now, just like in math, if they're on opposite sides, they cancel out. Kind of like spectator lines when we were doing that. Remember, we could cancel those out? So let's go ahead and cancel out what we can, and I think we'll find out that it works. So we cancel this one out. We cancel, they're on opposite sides, and so what I'm left with is the final. I can add them up, and I've got one N2. So there's N2. I've got 2O2 right there, and then I've got the 2NO2 there. So what I can do is I can just sum these together, and that's the enthalpy of that reaction. Does that make sense? So that is just, I changed the sign because I've reversed the reaction. I add those up, and so the answer is plus 68 kilojoules for that reaction. Now, they get tougher than that. That's a real simple example to begin with. But for you guys in here, do you know if you got it set up right or not? It's kind of, you guys have those problems every once in a while. You know, I know 100% I'm right. Or I know 100% I'm wrong because it's not matching up. It is not matching up. Yes, exactly.
So why'd you switch the NO2 and the N2O4?
This?
Yeah, why'd you switch that again? Sorry.
So I could get NO2 on the product side.
Okay.
Originally it was 2NO2 arrow N2O4.
Okay, so you're just
So,
trying to get
so what happens, if I've got an element, and most of the time it works that way. Sometimes they cancel each other out and you mess up, and then you'll realize that. But most of the time you look at your element within your individual reactions and see if it matches up with the final overall reaction that you want to find a enthalpy for. Okay? So let's do this one, and let's see what we can come up with. Our final product has to be CO2 gas decomposing in the carbon solid plus O2 gas. All right, so it's CO2 here on the right, on the correct side.
No.
No. So the first thing I would do is I would flip this reaction here. And I would write this on the reactant side and this on the product side. So I would go ahead and just go ahead and write out 3 CO2 gas plus 4 H2O liquid. Then I get my C3H8 gas plus my 5 O2, and I rewrite it, and so my change of enthalpy now is a plus 1332 kilojoules. Okay, and then what I could do is erase that. If I'm writing in pencil and that type of thing, I could go ahead and get rid of this part. But I'm going to erase it. I got that advantage. I can go ahead and do that so I don't have all that mess there. Okay, so there, that first one I reversed. Now I might have to do some more things, but we'll just have to wait and see if I have to do anything else. But at least I've got it on the correct side. How about the next one? Is it? Now the next one, I got oxygens and hydrogens. Well, hydrogen is not even in there. So that has to cancel out. Well, let's go to this one. Maybe I want to go to this one instead. Maybe not do the second one, because this one, I know carbon's on the left and it needs to be over here, right? So maybe I know there's no other reaction that has carbon in it, so I'll rewrite this one. So that this one would be C3H8 arrow 3 carbons and 4 hydrogens. And I reverse the sign. Plus 62 kilojoules.
Why did you reverse the sign?
Because I switched the reaction. Yeah. If I flip the reaction, then it's the opposite, and so I'll use my trusty eraser. Get rid of that so I miss. So now, what are we looking at? The middle one, we just need to decide if it should stay there or not. Oxygens, there's oxygens here, but the final amount should be just 1 oxygen at the end. So I've got 3 CO2 and I need 1 CO2. Okay, I've got carbon. I got 3 carbons here and I only need 1 carbon. Okay, and I'm probably going to end up with 3 oxygens on the right side, because what I'll have to do when I get the final answer, everything when I come down will be 3, and then I'll divide that final one by 3. So this is a little bit more challenging one, in that I match them up. Okay, CO2, CO2. Looks like when I bring it down, I'll have 3 CO2s when I eventually add it up. And then carbon, I got 3 carbons, and there's no other way they're going to cancel out, so I'll have 3 carbons. So I probably want to end up with 3 O2s at the end if I can. Okay? So how am I going to end up with 3 O2s? Because I got 5 over here, and I need to leave that one the same. What would I have to do to this one?
Multiply by 4. All reaction by 4.
This one by 4?
Yeah.
Yeah, because then that'll
There's
cancel
4
out your
H2.
your H2Os.
And
your
H2Os and the
H2s.
hydrogens.
Okay. So let's do that. We'll just go ahead and rewrite this and multiply everything by 4. And then that multiplies this by 4, right?
Yep.
So I go 4H2, 2O2, and then 2H2O. No, is that 4? 4H2O. All right. Make sure I get that right. So I got 4H2O. And I didn't reverse it, right?
No.
So then the sign stays the same, but I just multiply it by 4. So
That's
this
684.
So this one, I'm just going to go ahead and put down 4. I'll just put 4 on the outside, because usually when you multiply by 4, you just put it on the outside, and then you can add it all at the end. Okay? So, I probably want to, this is the one I rewrote, so I want to erase that one, right? Change the sign on that one there. Okay. Now, does it, when I bring it down, is everything free?
Yes.
Yes.
Okay, so, the O2 cancels out, and I got free here. The 4H2O cancels out. Good, not part of my reaction. The 4H2 cancels out. Okay, and the C3H8 cancels out, right? So I'm left with 3 CO2, 3 carbon, and 3 oxygens down here, right? When I bring it down, correct? So add this all up. I'm going to trust you guys to add that up. I'll double check it out.
Yeah, hey,
Yes?
when we add it up, don't we have to divide by 3?
Yeah.
To make those easier?
You're way ahead of me.
Sorry.
Is that
Isn't the change in enthalpy of the first one, isn't it 1332?
Yeah.
That's what we have on our sheet.
Yeah, I might have.
Up there, it looks like 1133.
Okay, let me make sure I get that right so that.
Instead of 1332.
Well, yeah, it's a plus.
Yeah.
There's still
But
This
it's
one
still-
up here?
It's got big, yeah.
It's
On our
1332.
sheet, it's, yeah, it's
1332.
1332 after you change the sign.
Was it a negative to begin with?
Yeah.
It was, but then we flipped it, so
Right,
it's
so
positive now.
1332.
Yep.
Okay. Alright, so we'll add everything up.
Oh, I didn't flip, no, I didn't flip the 62.
Did you guys get 710?
Yep.
So this would be 710, and like Ben said, my final answer needs to be 111. And so if I have 3 moles of everything, that's triple. So then I'm going to divide that by 3, and then that would give me CO2 gas, C solid plus O2 gas. And whatever that comes up to be.
236.6.
So 237. 237 kilojoules would be my answer for this reaction that I wanted. Okay, I'm going to have you attempt to do the last one on your own.
Oh, there's another.
I didn't notice. Another one.
And then see what you guys can do. I left space.
How'd you get 710? Because if you subtract
1332 plus 4 times a negative 171.
Oh, I forget. Wait, but if you take 4 times a negative, that would make it a positive.
No. If you took a negative
No,
4
it
times a
actually
negative 171.
Oh yeah, I'm not.
Yeah, you're thinking negative times a negative.
No, I was putting it to the 4th.
Yeah, no, it's just 4 times it. Yep, so it stays negative.
I don't know why.
That's okay. That's what you would. All right, go try the next one. I don't have the next one right now, so I'm gonna write that.
Slow down.
I like these, and the one reason I like them, I know if I get the right answer or not. It might take me a little bit longer than it should, but I can always. It's kind of like a proof, isn't it? You guys do proofs?
Oh,
those
yeah,
sucked.
proofs.
Well, these are better than proofs, I think. Because then, is it geometry you do that?
We did pre-calc too.
Geometry. I was terrible at geometry. Terrible. Proofs was not my thing.
Pre-calculate a bunch of them.
Wait, I wouldn't have noticed it until I went from 86 to 85.
Why is there 8? I wrote that down.
Well,
And then I got to look back up.
the reason I did this is yesterday's discussion where we had to look them up in the back.
Yeah.
So I wanted to get those. And then this is Hess's law. So Hess's law in the book problems come before what we did yesterday. So yesterday we did 83, 86B, 85B, where you're taking those enthalpies, looking them up, and then doing the calculations. And then this is Hess's law, 80 and 82.
Someone want to teach me?
I'm not. I need to do less.
How'd you do 66?
Yeah, that's what I need.